Yep. Hi, Eric and Chip. Chip, you're making me work hard. Eric, thank you for the new options.
Yeah, you know, I just responded to your email about pin C. I don't know what that is.
I'm guessing pin clear.
Well, I thought so. There is a thing called pin clear, but I don't seem to have like a short version of it that's just pin C, but let me, I didn't see it.
Wow. Check also for pin start being a pin S, since it's in the same group.
Yeah, no, pin S. I wouldn't have used that just for obvious namespace
Good. Thank you.
conflict.
Okay.
I don't know what the pin C was about. I mean, I have a pin clear, but that's it.
Okay, then I'll take pin C back out of the recognized names. I saw, I have, my highlighter now has a red color turned on for names it doesn't have a definition for. And that's how I'm finding these things.
That must have been a username or something.
It's not in the file. So we have an OBEX file that's referencing pin C as a command.
Could it have been for P1 or something?
Maybe the code was ported, but then not cleaned up. Would you have errored on the P2 compile with that?
Well, hey, everybody, let's start our meeting, and then we can get the chatting going. Let a few more people dribble in. I suspect with our time change to 1 o'clock, we're going to lose a few people, which already looks to be the case, although we had the same number of signups. So no amount of communication can fix that routine. And some people just won't be able to make it, like this guy who's stuck in class today. So his mom said he's going to ask if he can get out early so he could return here. We'll see if that works out. Oh, and I see lots of new faces too. This is great. I see Jason Pecor. Hi, Jason.
Hey, how's it going, Ken?
Good. Welcome to this.
Good.
And
Oh,
Thanks.
Jason.
yeah, nice to
Hey,
have
Chip,
you.
how are you? Thanks.
Good to hear from you.
Yeah.
And
Jason Pecor worked at Open Silicon for a while when we were working on the like the Verilog code for the P2, and their company did a lot of work on that. We even did a tape out with them.
Yeah, that was like 2011, I think, right?
Already?
It was way back.
Oh, God.
I think so. Yeah, it was a long way back then.
well, it's good you're here, and we see a few Europeans too who stayed up not as late. So that's great. Future Innovators Fund is going still, and today we got this one in. And it turns out this is pretty common among a lot of classes where the physical computing part of the class has been shut down because of COVID and hardware's not been sent home with kids. So it's a bummer, and it's hard enough here for these kids, but this one, the teacher's trying to win her interest back into she's a sophomore in high school, and we will be sending her a cyberbot. So she doesn't know she'll receive it, but we're starting to get more requests for this. It's great because we have at least $5,000 of hardware to share. We also posted 2 QuickBytes this week. Thank you, Francis, for this. Your material was super fun to work with for me, and it was a good learning experience. And I will copy this link into the chat, provided I could find the chat. And here's a link to the QuickByte from Francis. And this is great to have a community contribution. Anyone else, please come up with your ideas, and I'll help you a little along the way as much as I can, then post them. And Francis, by golly, he even placed an order like 2 days later, so I couldn't beat him to it and send him a thank you package. But thanks, Francis. And Propeller tool for Windows. I think y'all saw that yesterday. We made a release. It's a bug fix, and there's a video to go with it. I could find the link for the video if anybody wants it. And if you want to go ahead and install it, here's a link to it. I think I missed one thing though. This, yeah. I don't know how I overlooked this important slide. We posted this quick bite as well, how to use Visual Studio Code with the P2. Thanks especially to Eric, who's here. We haven't seen him in a while, with his FlexSpin compiler, and for Stephen for doing all the code highlighting, and then making it available formally in the marketplace, which finally caused me to ask Chip, shouldn't we have a command line access to the Pnut compiler so we could be programming Pnut, at least in Windows, using Visual Studio Code? So maybe we'll talk about that today. I'm curious if anyone set this up yet. So it's funny when we ask, what editor do you want to use? The majority say this editor, but it seems like the reality is most people are using the Propeller tool, but I can't really tell. Anyway, this tool is working well, so you know, with screen readers like NVDA.
I'm using VS Code, but not with Spin, with FlexC.
Okay, good. Last week we had 2 blind people here on the Propeller 2 forum, and they were telling us, it was really late in the day. I had gone home, and 5 hours later, I logged back in, and Chip was here chatting with them still, with 5 other people, right? And they were having some trouble with our tools, and I worked with one of them, Ken Perry, and he proofed this page very carefully because this works well with screen readers. So we set it up to be fully accessible for he and for the other fellow, Edgardo, I believe is his name. And then of course, we're having a sale. Come leave your money, take away some good hardware. Oh, this is kind of neat too. This is the first MegaTronics classroom use of the Propeller 2. This is from a customer, Gavin Garner, who is with UVA and has been with Parallax for many years. And I will post a video link of it. It's called a Geneva drive. I'm sure some of you know what this is, but here's the link. Put this in chat so you could watch it. Since we found out this really doesn't work too well over Zoom, I won't even bother. But I haven't figured out what all the pieces are here because he hasn't told me, but I think I see an OLED, I see an ammeter, I see a motor and an optical sensor. So he uses Propeller 1, Arduinos, and now Propeller 2, and is really moving all of the students to the P2. So they built 100 of these kits, and they outfit them all the same. This is their learning system, and has on it the P2 Edge up here and the mini breakout board. And so the students get to check this out, school-owned hardware, and then at some point they do their own project. So this is their learning platform. And he has another request where he's been asking me for a while to find some help. And it is for the following. I bet I can find someone on our forums to help me with this. But let me share another page. Maybe someone will jump out and say, I want to do this. He keeps asking me if I'd get Roy and Chip involved. So Roy, I'm definitely going to send this to you. I don't know how much time you have, but this is a Rosetta Stone comparison between Spin 1, Spin 2, and Arduino C. Let's make it a little bit bigger for you. And it's a 13-page document where he's trying to show them that how they can move between the platforms. So he's looking for some help in reviewing this, and he certainly will make it public so the others can benefit. There's a forum thread along the same lines of this that I think we've all been following. But if there's anybody out there that has good Arduino C, Spin 1, Spin 2 now experience, please tell me today, and I'll send you a copy of this and get some help for him. And then the other cool thing, and then I'll be quiet for a moment, is this Tic Tac Toe game that came in from Mike Harrison, who's with us today. So he's a teacher at Great Bay Community College in Portsmouth, New Hampshire. Portsmouth, is that how you pronounce it?
Yeah, Portsmouth.
Portsmouth. And what's really great about our customers is they buy things and then they send us things back in the same box. I think that's really funny when I get a box from Parallax, and it's just so nice that a customer not only place an order, but then they also liked so much what we do, they send us something cool they're doing. And this game is programmed in Blockly Prop, and it's, do you want to tell about it briefly, Mike?
Yeah, it's a Tic Tac Toe where we start out just doing 2-player and get that worked out. So that matrix of 9 LEDs, as he pushes those buttons, he's pressing a tactile momentary contact underneath there. And of course, you're just scanning the 3x3 matrix of buttons and watching for button press, and then turning on a bicolor LED. The flip is sitting on the back side of this. You see the header up there for the flip. So as Ken quite literally plays with himself here, he's doing the 2-player, and then he's going to flip the switch now, and now he's on computer AI. So as he hits the reset button, which is sitting up there in the top.
Right there. Okay.
Yep. So that puts it in computer AI, and it's doing a random to see who gets to play first. The computer got the first. And now he's competing against the computer.
I'm going to let him win.
Yeah.
It's like playing with a kid. You have to give him a win now and then.
And I was telling Ken, I did not do the full algorithm of tic-tac-toe for the ones that I built, because my grandchildren are young enough. I want them to have a win once in a while. You know, being 6 and 7 years old, we got to make it a little easier. So I have the first move randomized, and where I did not do the full strategy, it won't always be a tie game. There'll be times where you see the right pattern, you can make a win against the computer. And there's a little piezoelectric speaker up there. So that's giving a little audio feedback. And go ahead and flip it over, Ken. They can see how the flip is mounted. And I put it on a header strip, so you can actually pull the flip off of there for troubleshooting mostly, so we can undo it, you know, take it off and bench test any of the board itself. And there's a backpack on there that is the battery pack, and I put on the lithiums. That's my go-to battery now, because 2 of those puts out around 8.2 volts. So excellent battery to run any of these projects.
Great project, super well documented, and this would definitely be a class I'd want to take. But you wouldn't believe what a simple game of tic-tac-toe could produce, documentation and coding wise. And here's the bomb too. So students build it, then program it. Thanks, Mike.
And one of my students was asking a question, will we move this to the P2? And I said, it's really overkill. Matter of fact, the power of the P1 is overkill for running tic-tac-toe.
Well, now people are asking if they can get a kit for themselves. We knew that would come up.
Well, Blockly changes the dynamic a little bit, because I'd have to really stop and think about how to do tic-tac-toe in Blockly.
That's what that one is actually running right now, the one that Ken has. And I print out a couple pages of the Blockly. If Ken won't loan you his, Andy has one he can show you.
So what all we have to chat about today? Any topics or questions? We got free support here for an hour or 2 or 3 or 5.
I can tell you that the Spin2 syntax highlighting under VS Code has gotten much stronger. I was really focused on running through a huge amount of examples with the running through the P2 object exchange source code, running through the Pnut source code, the source code shipped with Pnut. I was focused on making sure that multivariable return and all the special variable access types such as bit fields and things like this all worked, indexing. And I've got probably 90% of all the spin examples in the spin2 document, all highlighting correctly. So it's a big step forward for us. You all have that release. If you'll just install spin2, it'll work automatically for you. The new thing with this release is that you'll see a iron sheet, a spin2 iron sheet syntax. What that does is disable the semantic highlighting. So you can see the difference between the two. That's all there is different between the two themes. So I always run with not the syntax version unless I need to go back and look, and then I don't have to reconfigure. I can just switch themes. I did move to the formal local variables. You remember were yellow in the last highlighting. I could show you if you want. I moved to lighter green, and all the spin keywords. Let's see if I can get an editor up and running here. Yeah. Had to make sure I had one running. Let's see here, share screen, find an editor note. I think that's it. Yeah, there we go. So you can see me here running through looking at just code setting in the OBEX. What you see now is these variables are no longer yellow, they're light green, so that all of the built-ins are now the yellow, which is a little bit more noticeable for us. Let's see here.
Stephen, do a bit of a zoom on your display in case people don't know how to zoom
I just
manually.
increased the font size a little.
I was going to say I wouldn't know how to do a zoom on my display.
Just usually control thumb wheel or something.
Yeah, control page up or control mouse wheel.
I think you can do that straight in VSC with a control plus and control minus.
Yep.
Yeah, there it is. Yeah, plus. There
That's
you go.
good.
Yeah.
All right, let's reproportion things then. I will get rid of the terminal. That wasn't the terminal. That was the whose videos are showing on Zoom. Yeah, so where can I show you? Here, for instance, you see the long move and the pin low, pin high. Chip, here's the one that I was asking you about. That should really be pin clear.
Well, let's see where, oh, pin C. Yeah, I don't know where that came from. Yeah, there is a pin clear.
Okay, so I'm guessing that should be pin clear. And so I'll take the highlighting out and make sure it just shows up in red. When highlighting is missing, when I don't understand something in the highlighter, and I'm going to have to look a little bit further for things like that, it will show up in red. And so as you're typing, for instance, here, right, first thing I do is make one not happen correctly. Thank you.
Well, that looks really pretty.
But it's getting there now. And so all the pad cards, yeah, great. Just when I tell you they're going to go red, they don't. So yeah, it's all automatic. It's working. We're in really good shape. I still need to fix within string processing and between string processing. And so I'll be doing that in the next release. And so Spin2's in really good shape at this point.
Can you point out the differences between the two syntax highlighting you have?
Oh, sure. What I'll do is I'll switch between color themes. You can probably see me doing this. Here's the syntax only one, and then this is the both. And so I'll select syntax only, and you can see what happens. Things that we can recognize by syntax without understanding more of the language are highlighted here. And so you have, you know, the method calls, and you have the control of the language. You have some constants, you have the pub and pry, the different sections, and things like this. We know numbers, we know strings, and we know built-ins. But when you go for semantic highlighting, you're actually looking at what is the intended purpose of these variables. And so these are parameters. This is the return value. These are local variables. And so when you add that information, so let's flip back to the other theme. When you add that information, we can understand a lot more about what the code is doing. And so we color them based on parameters, based on return values, and based on local variables. And now when you see that color show up here, you know what's happening.
That's awesome.
We're
I think
checking-
it's good that you just kind of kept all the operators just white. They're kind of neutral because they can appear everywhere for every reason.
Absolutely. And it's kind of a nightmare trying to, I'd call them out and highlight them. And so, yes, I left it as the base language. The base text color is the all the operators.
Mhm.
So I'm glad you like it. All right, I think that's about all I have. If you want to go to something a little bit more, let's see what we have here.
I have a question, Stephen.
Please.
You've updated this. I haven't seen any updates come through for VSC. Do I need to go back to and reinstall it, or how do I get an update?
Because of how we initially distributed it, we installed it from the VisX package, the VSIX package.
Oh yeah, I've gone past that. I've got your auto install, your out of the marketplace install.
Okay, good. But what happens is because of how we installed it, those stick around. So if you look in your .vs code directory, you probably have multiple Iron Sheet directories. What you
Right.
want to do is remove all but the one you installed, or remove them all and then just reinstall from the marketplace. And then
Okay.
it would go back to normal behavior when it advertises that you've got a new one and things like that.
Okay, I'll give that a whirl. And compiling and using the terminal, is that running through VSC yet or not?
It is running through VSC. You have to, for each project that you're running, you're going to create a local tasks.json file. And what you do is you go to my repo. I'll give you a link to that. Go to my repo or go to the QuickBytes. Maybe let's
Okay.
let's practice using QuickBytes. Ken did a great job of writing it up in a little bit more user-friendly. I give you the technical details at my GitHub, but Ken makes it a little bit easier to understand.
Yeah, I wanted to go through the QuickByte, so I just haven't had a chance yet.
Yeah, please do. And what he's gonna show you in QuickBytes is that you're gonna make two modifications to your VS Code installation. One is adding the keyboard shortcuts, which is VS Code wide for build and download. And then the second one is for each project tree where you have source code, you're going to add a task.json file, and you're going to customize that by the path to your tools and the name of your top level file that you're compiling. And that's all there is to it.
Okay, so you've actually got to, every time you start a new project,
Yeah,
you've got to go into there. That's a bit of a pain in the butt.
Absolutely. Now, with most languages, when you first do a build, it says, I don't know what to build. Tell me what your default build task is when you start new projects. What I hope to be able to do is put an automation in there that will find the tools you have, give you a choice if you've got multiple compilers installed, which one you want to use in this project. And then we'll automatically find your top level file and then add all that stuff automatically for you so you don't have to manually do it.
Yeah, I don't have to do any of that with Python. It finds it automatically.
Okay. Well, I
So,
find this
yeah.
confused others.
So there must be a way around it. Because if I pull in Python, I pull in, well, anything. I haven't tried compiling anything else, but if I pull in C++, it brings in a C++ highlighter.
Right.
So that I don't know whether they put that in the default coloring or.
Yeah, many languages are built in by default. And so I
Yeah.
would be surprised if we had it in defaults. The second thing would be that a number of the languages that I didn't find this too different, specifying a default build test. If you work with GCC and you use make files, don't you have to customize that?
I don't know. I don't use any of those. The only language I compile is Python.
Okay. And so what I found is that it's most normal. It is necessary for us to select what we want the default build environment to be for each project. So this doesn't feel too out of the norm. I don't like having to customize the task.json file, and so I agree with you there. I want to automate that as soon as we can get to it, but
Yep.
Not yet.
Yep.
And then a question for Chip. Didn't you tell me already that we can run Pnut from the command line?
Mm-hmm. Yeah, you can call the compiler from the command line, and you can call up just the debug display stuff with the display windows.
Right. And so what I'll do is I'll work on that between now and our next meeting. I'll put in examples for how to drive in the tasks file at my GitHub. I'll put examples for how to drive Pnut, and then I'll add a new task for starting the debug from Pnut and get those examples in. And then I'll also add a task for running FlexProp on the Raspberry Pi. So we can also see that happening there. And then I'll be able to demonstrate that you can sit at one desktop and literally remote into any of those environments and run them all from Visual Studio. Once you've identified how each is going to work. So it's quite a powerful environment.
Hey, Stephen, one thing, when you run Pnut from the command line, if it encounters an error, it will open that text file and show you the error. It doesn't report anything back to the command line.
Ew.
So
could I request that you do that?
What?
Could I request that you actually do report back to the command line?
Yeah, I can try to do that. I just got to figure out, I'll have to give you something about file.
Yeah.
Now I don't keep track of line numbers. I keep track of like position within the file. I could count the line number if it would help.
It would help a lot.
Okay.
Really all we need is line number, file name, and then the error. And then I'll send you information on, it's just really simple. You just put it in that order and wrap it in a convention. And then no matter which file, Eric, for instance, just added, he was putting out different file paths initially based on the depth of the file within the project directory hierarchy, or based on the include hierarchy. And if we put out different file name formats, i.e. some relative, some not, that can cause Visual Studio problems. It expects all relative or all absolute. And so as long as you're consistent, all relative paths from the top, from the directory containing your top file, or all absolute paths, we'll be able to handle the navigation to the files easily.
Yeah, I could reconstruct what the hierarchical path is during compilation.
Beautiful. So yeah,
and when you output it, you should output it to the standard error instead of standard out.
Okay, so STD error.
Yes.
I'm not sure what it's called in Delphi, but I'm sure the output to the console has the ability to select between standard out and standard error, because that's
I could even write it to a file. Would that be helpful?
No.
It needs to come
error,
back to the command line.
Correct.
So standard error is going to be one line of text or something?
It's going to output it just like you would do standard out. If you just do a normal print to the console,
okay,
that's called standard out. And then there's probably some way in Delphi to tell it to go to standard error instead.
Okay.
And then it will still go to the console, but it will be in the error channel, which is detectable by the program that called it.
Okay. So my message will be like, error, and then I'll have the file name backslash, or the hierarchy backslash file name, and then comma, line, whatever it is, comma, and the error. Is that what's needed?
There's probably a standard for that, isn't there?
There must be.
There is a standard way, and Eric probably knows it because he made FlexC do it.
Okay, yeah, I don't know anything about it. I don't even know what STD out is. That's a C thing, right?
standard error and standard out are the two output channels for any command that's run. And
It's actually a old school DOS hangover.
correct.
It's called standard out and standard error in C, but that's just how you pick between the two DOS channels to go to the command line.
It actually goes back earlier, and that's in CPM.
It's a carryover from Unix.
Yeah, I know. I'm just saying.
Yeah.
Yep. It's the very first command line operating systems had this, and they've been there ever since.
Yep. Probably 60s.
Easily.
I'll try to get it together.
Sure. And I'll work with you, and I can test it as immediately as you have a draft for me. I'll put the thing together and get it working. Yeah, that because what happens then, Chip, is once you put out that information, Visual Studio picks it up and then highlights the individual files, the file names on the left column you saw. It'll actually mark them in red, saying they've got errors. And then as you navigate to each one, the errors will be shown in the code and be parsed out of your error messages and actually shown in the code on the appropriate lines. It's all automatic.
Okay, you know, because we do everything, because I figured the person can only see one error at a time, we just stop at the first error.
Yeah, I just had Eric make a change so we don't do that because it's inefficient with bug fixing, right? If you've got 5 or 6 small things to fix, it's much more efficient to fix them all and then go. There are people that like to work one by one, and there are people who like to work with as many as they can at one time. It probably came from that it used to take us hours to do builds on larger systems. And the last thing we wanted is make one fix and wait hours and make one more, wait hours.
No, but this comes from the mindset though of like split second
Yes.
compile, download, execute. So
Agreed. Agreed. And the nice thing about this is that we can use the compile and re-highlight the files now with FlexSpin and with Pnut, and it's nearly an instantaneous cycle. So yeah, we can work that way.
16 analog
if you can put out more,
and
please do.
2 digital channels.
Oops.
okay, so okay, now the implications of doing this is that we're not even going to be doing any kind of GUI stuff. Would
Correct.
this make it easier to build some kind of like generic container that can run on other OSs if we're not doing any API calls? Well, we're doing disk IO. Well, I guess there's all kinds of stuff that goes on under the hood in Delphi that's
Well, this
machine-
is, yeah, you're really brushing up against the reason why we've been asking you to port it off of assembly is because we think of it, we truthfully do think of it, no matter what you're doing with IO, we think of it as a disk only operation. And it's easy to port and move because compilers are just that in our minds. And so we had already moved to that in our own minds. And maybe that's why you're finding it harder to hear us.
Yes.
Yeah, this VSC gives us that whole GUI stuff. And of course it's cross-platform. They've even got a native Apple M1 code now.
Visual Studio now works native environment.
Yeah, it's not in Rosetta emulation, it's straight M1 code.
So the idea to have Pnut accessible through Visual Studio Code is really nice because then we can compare Pnut to FlexSpin and then politely ask Eric and provide our code to do his best to chase the rabid running dog through Red Bluff, California. We just got a haircut. Looks good, Chip.
$8, 7 minutes.
Wow. Should we talk about debug? I think there's some debug questions. JonnyMac and Next Big Robot.
Do it.
Yeah, John had some questions about the plot.
Yeah, can I share what I'm doing just so you can see?
Yep.
So this is can you see this screen?
Yeah.
This is a plot screen that I made for a transmitter. In fact, it's this one. $60 for an RC transmitter with a 10 channel receivers. And these apparently these FlySky are pretty popular with the budget RC community. So I got one so that I wouldn't mess up my Spectrum gear that's attached to my Elevate. At any rate, right now the transmitter is turned off. If I turn it on, you'll see that my little faux LED turned green, and now the channels all operate. This is a 10 channel, so you can see I don't have channels 11 through 18 operating. But this is coming from the receiver as a one wire. This was an extended experiment of my sbus decoder. I have a friend who works in the movie business. It needs to take sbus input from a RC receiver to control big, giant dynamixel motion, devices. And so I got the receiver working, and then I wanted to do something graphical. This forced me to try to learn the debug.
So you did this with Plot, huh?
Yeah.
Well, it looks good.
I'm happy about it, but and this is going to be my opportunity to master the plot window, because from my point of view, and if I'm wrong, correct me, please. The plot window gives us the ability to do the most customization. We can create a custom output. And in fact, when I sent an email to my friend with this image, and he was really excited. He's been a little slow to adopt to the P2. In fact, he hasn't yet. But when he saw this, he thought, oh, hey, that's cool. And, again, it's all live. In his particular case, he could have this running and also sending data out to a device and see, the live data plus what's going on motion-wise. You could also use it to tune the transmitter and that. So yeah, I'm quite happy about it, but now I want to learn the aspects of plot. So I think, Chip and I were texting about 10 o'clock last night and didn't have the opportunity to talk. And I thought, all right, I'll work on this a little bit. Well, 4 hours later, it was finally done. So I'm a little ragged today, hence the camera is off. So at any rate, what I'll do, Ken, is I'll create a QuickByte on using Plot, because again, it's the most flexible of the debug outputs. You can create custom graphical things, but there are things that you get used to. For example, for those who haven't used it yet, this is the origin in the plot window, where in normal computer graphics stuff, the origin is up here. And I was struggling with that. I thought, why are my things not on the screen? So that's a change that if people that are doing normal computer graphics expect the origin up here, and it's actually down there, which creates a little bit of consternation, because as you want to grow your window, you have to readjust for where things are. Whereas if you does that make sense, Chip, what I'm saying? Because if I make a taller window, everything is going to be misaligned. So the one thing that I was having trouble with, I started to do this. I made a thing where, again, this works and I'm happy with it, but I wanted to start to learn things. This is what I'm doing now. So these are actually box commands. If I use the line command, it looks the same, except it has rounded ends. And then I thought, well, let's try the oval thing. This syntax did not work, and I don't know why. But just a couple of questions for clarity.
You just need to do a set to define the box center, or to define the oval center, and then
it's here.
Oh, okay. So you've got that done. Okay, and then let's see.
But the oval fill, this is a question. So you see here on this this document, it says oval fill. You define the actual, left, bottom, right, and top. See, it would be nice if you just had a width and a height in there, like it, for example, with the circle, you just give it a diameter and it draws it around the center. but with
Right.
ovals, you have to give it 4 parameters. It would be nice if with the ovals, you just gave it 2, so they
Well-
just had a width and a height.
Okay, let me go to the document and look, because I don't, where did you get this text file that shows this
It's
stuff?
in the downloads of the with the code. I mean, I'm assuming, I thought you had done this. Let me see up at the top. Yeah, this is not something I created. This
I
is
did, oh, I did that a long time ago, but everything's changed since then.
okay. Well,
Yeah, that was like
this
my
should be
work.
taken out of the downloads.
That was my personal notes early on in development, and now we have the formal, the Google Doc that shows all this stuff.
Well, this is what I was, this is why I was up until 2 o'clock in the morning. I'm fighting between the 2 documents, not knowing which one runs. Okay, well, that
Yeah.
makes that fixes things then.
So many things have changed since I made that text file. I mean, I quit working on a text file and I put everything into the Google Doc, and the Google Doc's up to date.
So, all right. So there's the key then. I'm going to just close.
So for oval, now you just say oval and you say width, height, and then you have 2 optional parameters, line size and opacity.
Okay, so it is like the circle. Now,
Yes,
hang on.
except you have an X and a Y, not just a diameter.
I thought I had.
While you're there, why don't you grab that Amazon link for us
What, this one?
at some point for the sbus transmitter receiver pair? People on the chat are asking for it.
Oh,
We want to buy one because we know where this is going.
copy. Where's the chat?
Sorry, I didn't mean to disrupt your train of
That's
thought
all right.
now.
Well, yeah. So since I had it highlighted, I knew that was going to come, so I had done it. But let me. Now I can't. Well, since I'll paste it in as soon as I stop sharing. I can't
Sounds
find
good.
sharing. At any rate, the what I was going to do, that's not flying today. To documentation. Well, I can look through this later. All right, I will go back to that then.
Okay, go down. What you do is go about
Yeah.
go about 70% of the way through the document, and you'll be right on the plot display. A little more. Get aggressive, go faster.
I'm spinning my wheel as fast as it'll go.
You can grab that little tab and drag them down.
Well, what I have the zoom windows all over the place. So it's
Okay,
some things are hidden.
you got a few more to go, I think.
Wait, I can just click on that tab right there.
There you go. There's plot. Okay, so here are all the commands right here.
Okay.
Yeah.
All right. So again, now I'll beg forgiveness because this was happening at about 1 o'clock in the morning and I was drinking whiskey. So, which did not help me sleep after, but I did get a working display. I am happy about this, which I think is quite neat. Again, my friend who works in the movie business, very happy about it. It's going to help him, but I want to do neater things. Like what I actually, for this kind of display, what I want to do is put a point on one end. So that's where, just for clarity, since I do have that window.
A point on one end.
Yeah, so take the shape of a home plate, in baseball, if you ever played baseball, and make it tiny. So,
okay.
so it's a literal pointer, so it's got a point on one end. So in that case, and part of this, I don't really need that, but this will give me the opportunity to show people how to create custom shapes and put them into their windows. The whole idea is my original thought was to bypass this completely and just send another serial stream out to processing. But frankly, I don't want to do that. I'd just rather go ahead and do this on the inside, especially since I think Roy is working on being able to open this up. So, correct, hopefully Eric will be able to include these kind of things in his stuff. And then everybody will have graphical debugging that's kind of native to the system. That would be nice.
John, can you tell us where you found the other document?
It is when it was in the examples folder. Well, here, I'll just.
I don't think it's, oh, Jeff might be putting it in the Propeller tools.
Well, that's, yes. Yeah, I didn't create that. And it somehow came with, so
Oh, those are our very first examples. I recognize them.
well, this is the latest install. Oh, this is 2.52. And I thought, I got it from this folder, so it's in here somewhere. But
okay,
it was something that it's in the downloads package, so it should probably be removed.
Yeah.
I'll draw his attention to that.
Yeah. Okay. Well, that probably would have, and I assumed since it was in the latest downloads, it was probably fresher than the other document. My
I
mistake.
think it was called debugmodes.txt or something.
Yeah. So, sadly, I closed it. Well, here, I know what I can do is I can get it from here. README debug displays _ README debug displays.
Yeah, Jeff had renamed that file.
There it is,
Okay.
right there.
Okay, I'll write to Jeff and tell him we got to pull that out.
I already got it covered, but maybe you could tell us where are the current zips of debug, because we don't have it like a QuickByte. I don't think they're on GitHub. So
Well, the Spin2 documentation covers all that.
but you have to copy and paste them out of there, right?
Well, yeah, but it's just text.
But they're,
Yeah.
aren't they also in Pnut though, Chip? When you don't you incorporate those into your Pnut?
I don't put all the text in I put some things in, but not every one of the examples, because they're made so you can just copy and paste them right from the documentation and run them.
All right.
So I thought it was superfluous to bother adding, and that way I can just keep changing the prime source if I need, and then everybody just copies that.
But then,
want to.
so if I go to the document, if I do a Control F here and look for, say, that may, was it polyfill?
No, I don't have polyfill anymore. See, all I have is like stuff to do boxes and
Oh,
ovals.
so there's no more multi-point polygon?
No, because see, Windows was doing that for me.
Okay.
Polygons are like a whole nother level
All right.
of stuff.
Okay, well then I can give up on that. So, all right.
If I put like a triangle drawer in there, that would be like the basis for all those things.
Yeah, that's fine. It's not necessary. Again, it was just to make a neat looking display. Again, ooh and ah sells product.
Yes.
Now this is probably ooh and ah enough. Again, it certainly got my friend's attention, and but I wanted a nice little point on the end, especially in the case if it was a if I had a scale, of values up there. But if I end up doing that, what I'll do is I'll just draw this fat line, because this is a box now, but I would do that perhaps, and then a skinny line to act as the pointing part.
Right.
Yeah, anyway, it was, all right, so their syntax questions are gone now, because I think I'm asking just for double checking. We need to use this syntax whenever we want to pass a variable along, right?
Yeah, well, what that does is that the backtick parenthesis is like a shortcut for signed decimal, I think. And it just makes it, it's just a shortcut. So you're saying output X and Y plus 10 as decimal values without saying X equals, just print the values with a comma between them.
Well, yeah, and I'm not even looking at this display because I'm running this every 25 milliseconds to
Yeah.
match, fairly close to the receiver output, which is every 7 milliseconds.
Yeah.
But in general, and I'm asking this because I'm going to write this up to help people. If since I'm passing a position, I can't do this, can I? Oops.
No, it'll send that out as a literal string.
Exactly. So
Now you can, if you grab the top of where it says debug output to freeze it, just grab the top of the top bar of that window, just press on it. Now you can see in there the set. Let's see, do I see a line there? Look fourth up from the bottom. Is that one? No, this one would just have just the word set and then the line command in it. Well, no, maybe on the bottom one. Would that be it? No, because we're just looking for a set and then a line and then some values. Let go and click again. We'll capture it.
it is drawing lines all the time.
Yeah.
So there's P black set 50, 100 line space 45, 425, 100, or space 1.
Yeah, right. And that thing throws away commas. It looks like white space. It just looks for the values. So it says set and it looks for 2 values, and it says box and it looks for at least 2, maybe 3 or 4 values.
All right. Well, like I said, after, a glass of whiskey and a lot of frustration, I did get this working, and this looks really nice. And it's when the receiver is on, it looks.
Yeah, it looks great. I mean, in an instant, it conveys what's going on. You've got 18 channels.
Yeah.
And they range from 0 to, well, whatever they are, it shows on
0 to 2047 from the sbus. Yeah, now you can see, I think I need to re-download my program. Let me do this really quick.
John, did you mention what receiver device you're using?
It comes in that packet. So it's the Skyfly FS IA10B. So it has 10 servo channels output, parallel servo channels out, but it also has the sbus output. Now the Skyfly, they have their own protocol. sbus is a little interesting in that it's an inverted signal. So the idle point of the line is low, and then it goes high for a start bit, and then all the bits are inverted. It also uses a 9-bit value. So there's 8 data bits plus a parity. Okay. And then there's 2 stop bits, which is not a problem. And the nice thing is, if you want to see it here, this is the receiver code. I use a smart pin to act as a receiver. Now, in this case, I have a constant here that is actually built into the assembly code here. So it's just async and it's inverted. And then the bits are set to 9 bits.
Sweet.
And since this is inverting, I don't have to do anything. It just comes in, and then so this goes through what I'm doing is this runs in what's called sbus fast mode. And for the record, so the FlySky have their own protocol called ibus, but you can go into the receiver configuration and tell the serial output to be sbus. So you have both choices. Again, sbus is going to be a packet of 25 bytes that are 9 bits each. So there's a parity bit in there. And what I end up doing, and this was something that Evan in the forums pointed out and Chip confirmed, since what I want to do is wait for that idle space between packets, I have to turn off the smart pin I was originally just doing this, but then Chip and Evan pointed out and Chip confirmed, you actually have to clear the smart pin value to restore the normal tri-state behavior of the pin. So this little loop here is just forcing the thing to wait for 250 microseconds, which is a little more than 2 bytes that period. And because we say, okay, if 2 byte periods have gone by and there's been no activity, we know that there's nothing. And I'm testing every microsecond, and a bit, the sbus runs at 100 kbaud, so a bit is 10 microseconds. So it's I'm getting 10 checks per bit here. So we know the line is quiet. Once that happens, I restore the smart pin to UART. Thankfully, the X and Y values don't get bashed during this process, so I don't have to reset the bit period and turn it back on, and then it goes through and does the receive. I had taken it out because all of the Schmarshmino examples of sbus, everybody ignores the parity bit. But I went ahead and put it back in. So it's a very simple thing of after the pin comes in, you shift it right, after the byte comes in rather, shift it by 23 because there's 9 bits in it. And then just count the ones, and C will hold the LSB of the ones count. So if that's odd, it's a bad packet because this uses even parity. And then one of the things I really like, I'm trying to get better at, is this section here stores the byte as a byte in an array in the cog. So with the P2 with spin or PASM2, it's much easier to deal with bytes and words as array elements in the cog. It's really nice. So after that, this just verifies the first and second byte, or the first and last byte. The first byte is OF and the last byte is 00. That's the only sanity check that you have other than the parity thing. There's no checksum in the packet. And then once that's done, this goes through and unpacks the data. I got a lot of help from Evan and Tony B because the channel values are 11 bits, but they're packed into 22 bytes. So you take 16 channels of 8 and pack them into, 16 11-bit values and pack them into 22 bytes. So this unpacks them. And I had started with something that, because I found after I'd already gotten heavily into this, what's his name? Jason Dory had written an sbus receiver for the P1. And his unpacking algorithm counted on the bytes being reversed, being flipped bit order. And I started that way, and then after finally absorbing it, found, okay, I don't need to flip the bytes. And in his case, he's bit banging because it's a P1, so he could receive them in any order he wanted. And so he would receive them in backwards, do his decoding, and then reflip them. In this, it worked out really nicely. And in fact, this works as fast as his does, but without the hassle of having to do flipping and flipping. And this allows the use of the smart pin, because the smart pin only knows, LSB first for serial. And yeah, so yeah, pretty straightforward. There are, you notice there are 18 channels, bit 23 of the stream, or sorry, byte 23 of the stream has 2 bits in it that are for channels 17 and 18. So they're just digital. So they're either 0 or 2047 from the user's point of view. And then I have, then there are other flags. So if I go back to this, hopefully it's still working. Let me. You saw, oh, not that, F10. When it's off now, and it says fail safe mode. So what happens, I'll turn the receiver on. Oh. So now the receiver is detected on. If it seems to tolerate losing a couple of frames and just outputting the last values. But for example, so channel 3 is the throttle, and why is it not working? So, oh, there. So I have a real problem because I'm not touching the throttle or anything, and it's doing its own. So I have no idea what's going on. Let me slow this down. Sorry. Live demos without testing was silly. It will seem to be working perfectly before. Maybe I'm overrunning data. All right, so now it seems better behaved. The receivers are set up so that they have, so I don't know, I'll try to keep this near the microphone. So you'll hear the switch go off. You notice it was kind of a 2-step process. The LED went red. So that's the loss of frame or loss of signal bit in the error channel. and that flags byte. And then after, I think what happens is it decides, okay, it's not coming back. So we're going to go to fail safe mode. What happened is that I had the throttle all the way up. You notice the throttle is at 0. In one of the transmitter, you can configure for how it behaves in fail safe. And the default configuration that is recommended is turn off your throttle channel, leave everything else alone, but turn off the throttle. Now what'll happen, the transmitter doesn't like certain configuration when I turn it on. So you'll hear it squawk when I turn it back on. And what I have to do is reset all the switches to the off position and the throttle to off, and then it will allow it to start transmitting the new values. So there's, anyway, the sbus decoding seems to work. I'm backporting my code to the P1 also for my friend, because he's using the P1 in movies and TV now and wants to have an sbus decoder that does what he wants it to do. But anyway, sorry, I'll get away from sbus.
Hey, John, try changing, now that you know how to do the oval, you could code it right and see it.
So
I guess you just pick a different case and then make sure the oval thing is right.
yeah, what I have to do is put this back in.
So just put oval and then
So I want it to be 20 by 5.
okay, you don't even, okay, then.
I don't,
oh,
since they're constants, I can
position it
just
there.
do, is it width and height?
Well, you have to do you've already done the set, right? Yeah, that's all you
Yes.
do.
All right.
Yep, now run that.
Yeah, nothing.
Let's see, let me look at the thing real quick. You would say oval, width, and height.
Oh, wait,
and
I
it
have
should
an
go. You have
extra
the color.
parentheses in there that it
I don't
didn't
see
squawk
anything.
about.
Oh, oval. It's just oval, not oval fill.
So that probably
Or
should
oval
have
team.
generated a syntax error.
Well, see, the thing is, it's all open loop. It's happening.
But when the compiler parser, if it saw that, or does it not, look for that.
Well, all it knows is that's a string.
There it
could
is.
be anything.
Now it's working.
Yep.
That's a little nicer with a pointy thing kind of on it. Anyway, my goal for this is twofold: to help my friend with a tool, and then to learn how to use this so I can write up a document to get other people doing custom displays. Because that's where we can have some real fun, especially I think for, because I know how much Ken does work with, student robotics stuff, but it'd be really neat to see, all your robot stuff and then watch its behavior out in the field and have it more than just numbers. I've got the numbers on here, as you can see, but there is something nice about having this live visual indication of what's going on.
John, I couldn't find the 18 channel version of that. So before you sign off today, get us a link, because we're all wondering what you're really using.
Oh no, so Ken, here's the thing. I don't know that Skyfly has an 18 channel. The sbus protocol supports 18 channels, and the receiver is in fact putting out 18 channels, but since it's only a 10 channel device, you see it puts these channels at center and the digital channels at off. So you can notice, these, these I'm switching now, these are switch channels. It's interesting that their low value is 240 and the high value is 1807. There is one of the switches actually has a center point on it. So there's, of the 4 switches, 3 of them 2 position and 1 of them is 3 position. But anyway, for $60, it was absolutely worth getting it, because, this is a real inexpensive robot controller, and it just takes 1 pin into the propeller and you get up to 18, depending on the transmitter receiver you're using. But even 10 channels of control is very nice for $60. And
it's amazing.
it's It's a simple, you know, in the object, you know, there's really nothing to do except ask for the channel value. Now what I'm doing is, and this goes along with my style of programming, you know, so has signal, it returns true if we have a live signal. And so it makes the coding, this is what I'm trying to teach youngsters to code this way, because you'll see it says, if you look at the code, it says if sbus has signal, well, that becomes self-documenting. And, or the same thing is if sbus in failsafe, because this flag will set first and this flag will come after if too many frames are lost. But most of the time you're just going through and you're using read to read the channel. Now, because of the way that people, you know, it's my perception is that people treat the receivers, you ask for it channel 1 to 18, not 0 to 17. So that's why I've added, I'm using a 0 to 17 here, but I'm adding 1 there because the object expects you to ask for channel 1s to 18. And there's, you know, you can pass default values and other things, but anyway, it was a fun exercise, you know, because I learned a little bit more about PASM2. Especially, I really liked doing the table stuff in PASM2. That I think is going to open up lots of neat things, that even for beginner PASM guys like me. But I want to be able to do more custom stuff here without resorting to doing using processing. Yeah, so it'd be really neat. Although I'm not asking for this, Chip, so don't, if I could, you know, if I could take but I was thinking I would love to have a graphic of this receiver and, you know, as an image and then draw over the top of it, you know, so it looked like I was manipulating it live. And I can.
What do you mean draw over the top of it?
Well, to have a background image, but I don't like using.
I see what you're saying. Gotcha.
Yeah. Yeah, and then draw over this. So it looked like, you know, this is nice because I can see what's going on. It would be nice to see if, you know, to follow it. It's a fun, goofy thing. But there's probably some areas where that is going to be the case. But what I would suggest to us as a community, you know, if we're going to do these debug things with Spin2, you know, create little. Not an object, but little chunks of code to say, hey, here's how you do a dial meter, you know, or here's how you can do this kind of meter, so that people can make really nice debug displays. So again, I think particularly in education, that will be really, really beneficial for people that are using Spin. And then maybe, again, with with Roy, what he's doing, if the debug capability, this graphical debug capability, can be extended to other languages, that would be nice too. Anyway, I'll stop now.
Yeah, well, you know, it's kind of agnostic. It just looks at incoming strings, looks for that backtick as kind of a trigger, and then it parses it according to its own little set of rules, and then opens windows and updates them. I mean, you could run that, like the Pnut has a command line option. I think it's just -debug, and you can give it a COM port and a baud rate, and it just opens up, and whatever is sending out those strings will it'll get interpreted by that debug parser and show stuff. It has no idea if it's coming from what kind of a microcontroller or any kind of system. It just looks at the data coming in, and the data is fully. That whole thing, it's fully documented right in that Spin2, you know, you have to come up with the things to print the numbers and all that business. But
yeah,
if you can print those numbers and then you can meet these, like, you know, oval, you know, have a width number and a height number. That's all you got to do, and it'll do it. It'll show all this stuff.
Okay. Well, anyway, like I said, it was a little frustrating at times, but I think in the end we're staying up till 2 o'clock in the morning to get it to work. And now I think I got a better hand. So again, I'm repeating myself, I think, but the plot window is the most flexible of all the debug things. And so, you know, maybe some attention should be spent, and I'm starting to explain, especially to newcomers, yeah, here's how you can create a really neat output to check what's going on in your code.
Yeah, Plot can be used to
Flying by are not helpful.
Yeah, Plot is like, it can be used to recreate any of the other windows in appearance. It's just not really data type aware like those others are. They're specialized for certain data streams, but this is totally putty. You can make it into whatever you want.
Is this going to work with VSC?
If he calls, if he can shell out to our thing and open Pnut and have it read those strings in, it would work.
So, Chip, you're suggesting that we can do it with Pnut because you'll have that as runnable as a separate form. Agreed. I think Roy's work is making it so we can run on any platform we can build Roy's version. And so that means we'll be able to have it on Macs, and we'll be able to have it on Raspberry Pis as well.
Mm-hmm.
So,
Roy, are you, did I send you guys, I sent you guys the code for all that stuff, right?
You sent it to me, yeah.
Okay.
I'm porting it to C, and I'm assuming we'll be able to just incorporate it into load P2 so that FlexProp can use it.
And then if I make changes, of course, you can do the compare thing and see what changed, because sometimes I find little like floating point bugs that need fixing. And it always comes down to just like, maybe the same line of code with like a, I don't know, some few extra words on it or something.
Yeah, no, it's not a big deal.
So just to clarify, Roy, if you're successful, then we'll have the debug available with FlexSpin on Mac and Windows and Linux. Is that what I'm hearing?
Yeah, if I get this thing ported and we put it in load P2, it'll work with everything FlexProp on all platforms, all languages, because it's in load P2, like it's just processing the debug strings, right? Eric will have to add the support for outputting those debug strings into the various FlexProp languages.
Right.
I think it's partially there for Spin 2, but I don't know if it actually parses, produces the debug runtime that goes into the P2, right? I don't know if it does that yet.
No, this is great. Well, I can see Ray is smiling.
Yeah, Ray, you got my message that the reason that debug Baud thing wasn't working right in, it is working for me in Pnut. It's just not working in Prop Tool, and Jeff said he's aware of that, and he's going to go in there and he's going to make his code sensitive to the Baud change.
Chip, it's a Pnut problem. I was not using Prop Tool. I haven't actually loaded Prop Tool.
Yeah, I saw you said that too, but it seems to work on my end. I wonder why.
Well, when we get to the end of this, I'll show you it on my screen, because I've just redone it and it's absolutely hard on.
Okay.
There's definitely a problem, and I'm using Pnut with the P2 eval. So I've got all the other stuff out of the mix, and I can go in there and one comment works and uncomment it back in, and I get a blank debug output.
Yeah, well, let's look at that and see what it is. In fact, we could just go into that when John's done talking about this stuff.
Yep. Really interesting, John. I love it. I love what you've done, John. Geez, for a $60 or $70 remote control, golly, my poor DXi 6 was a damn expensive unit, and that's about the fourth of the big units I bought. Gee whiz.
Well, when my friend asked me about doing sbus stuff, I didn't have a tool, and I thought, well, let's go looking around. And it turns out that even though these are really inexpensive, these FlySky models, in the RC community, they seem to be quite popular, and people say they work well. So I thought, well, all right, for 60 bucks, let me take a chance. And there is a lot of support for them on YouTube. That's where, you know, I didn't know anything about this and, you know, went through and for example, how to do that configuration setup and get it converted from the sbus output or ibus output to sbus. Now, the interesting thing about the receiver is that in the ibus configuration, it actually has sensor input. So ibus is two-way. So I'm going to work on that down the line. It'll take a little bit of work. It's interesting. There are two ports on the receiver. One says it's got a little thing, ibus on it, and then the little lines that go to the two ports. One says servo, the other one says sensor. The servo is just a transmit output all the time. So it's just sending that data stream that I'm receiving here. So that's why I'm plugged in now. On the receiver, on the sensor side, it's actually a half duplex line. So you can have, since these are multi-drop, the sensors, you can have multiple sensors on there. So when you tell the radio, hey, I have these sensors out there, that particular port sends a small packet that is telling, you know, which sensor it wants data from. The sensor responds back, and then that's transmitted back to the main device. So there's a little bit of shenanigans going on there, but I want to figure that out too, because that would be really useful for, I was thinking about Ken's boat project, you know, where he's got a boat, remote control boat out in the middle of Lake Tahoe. Now he could use one of these receivers and see data right on the screen.
See his battery.
Yeah, well, that's a nice thing too, because
I'm glad you took the chance.
The nice thing is, you know, that's the receiver voltage and other voltages, you know, those are things you could send back. So you could actually monitor that. I suppose you can do that too with XB, but you know, again, this was I have a really close friend who asked me to do this, and it seemed like it would be a useful thing for the community too. So hopefully it will. And now I feel pretty confident in the object, so I'll release it. I'll send it up to Jeff with a little bit of a write-up, and then I'll include, I have two versions of the demo. I have one that's text-based that works in Prop Tool, and I've tested it with Flex GUI. It works fine there too. And then I have this one, which is Prop Tool only, of course, because it's using the debug statements.
John, there's nothing special about this program that wouldn't run on the P1, is there?
Well, it is yeah, because the P2, well, first off, the code that I wrote is for the P2. I am backporting it to the P1, you know, and this is where you find out how efficient the P2 assembly code is when you port it back to the P1, because there are many P2 instructions that take 3 or 4 or more in the P1 to accomplish the same thing. I think my P2 code is about 300 bytes compiled, and as for the assembly object, and in the P1 it's about 450 right now. And I haven't tested. I've written it. I just haven't tested it. So I will, Jim, have P1 and P2 versions. I started with the P2.
Thanks.
And for what it's worth, there is already an sbus object written by Jason Dory. It's in the Elevate GitHub files. Now it's a very small program because he's wrapping that in a C shell for the Elevate stuff, but there is a spin driver for sbus that's available already that Jason Dory wrote. In fact, I'll put a link to that so that people can get to it.
Hey, Andreas Bank asked a question. He said it would also be cool if debug strings could be generated in code in a string buffer. I think this does not work. Andreas, what do you mean exactly? I think what you're saying is just generate all the strings and then output them asynchronously or in the background. Is that what you're talking about?
Actually, I wanted to try to have a general object for, say, digital output, and the number of channels would be generated in the code then. So that's my first try was to simply write all these nice debug strings into a string buffer, but found out that it doesn't work like that. So
Oh, I see what you want to do. Okay, you want to have
yeah,
the debug strings in a buffer.
that would allow to have configurable objects which allow logic output, for example, with a flexible number of channels
Nope.
and stuff like that.
Okay, you can do that, but you won't be able to take advantage of things like that automatic syntax where you have backtick and then parentheses and the variables that will get printed out. You can generate, because all that stuff it's serial going out. There's nothing special about it once it leaves the serial port. So if you can match the syntax that's in like that spin2 document that shows how all those debug displays work, if you can simply generate that stuff however you want to do it, which means you'll have to have like a little number printing routine, right? If you can do that, you can pull up all those strings you want and send them out, and you can completely genericize it. Wait a minute. You're going to have something though that sends those strings. You're going to have to do like a Z string or a string L in the debug in order to get the debug interrupt to occur. But you can compose all the data ahead of time separately. Does that make sense?
That would make sense, yes.
In fact, wait a minute. Do you need to? Yeah, because you're sending it out. You know, you could even just send it out on the serial port. Just send it out on P63 without even doing any debug. That would work also. Then
yeah, I'd give it a try. Yes.
Yeah, you can picture that, right?
Yeah, understood. And the other one would be a question, is it planned to have some way back from the debug? So maybe you have a variable in your code, say frequency, and you have some input field in the debug, and then you can live update the values in the running code.
Yeah, that's next. I've been delayed because I've had a few little detours along the way, but I'm working on a single step debugger. And when that gets implemented, we're going to start having two-way communication. So we could come up at some point with something where you can become sensitive to like mouse movements, you know, over a window and respond however you want. So yeah, that's something that's on the horizon. So the debug will become bidirectional.
Okay, cool.
It would be fun if we could draw a box on a debug window and drag it with the mouse and have that come back. So that slider that I'm using as an output could be, we could draw something similar and use it as an input.
Yeah, well, what we could do, I mean, in the simplest form, all this has to be is a message going back to the P2 that says, we have mouse movement on this window, and the mouse is here, and just like Windows messages, the mouse is here, the mouse has been clicked at this point, the mouse is positioned at this point, the mouse is pressed and dragging to this point. These kind of messages could then be discerned on the P2 side, and then you would, so it'd be kind of low level. It wouldn't be like object based but the window, we'd have to have a way for the message to come in, and then it has to go out to the code of interest that runs that window.
And then that would update the position of the object that was being quote unquote dragged.
Yeah, so you'd be responsible maybe for looking at the coordinates and figuring out where that lies on your window and what that means, if anything. But that's the most open-ended, you know, and it really doesn't take much code to handle that kind of stuff.
Okay. Well, then it goes to, sure, we can do a really neat output window. Now we can do a really neat input window.
Yep. Yeah, and we need all this. We need all this business for doing the debugger, because it has to be interactive. We have to be able to click on like, okay, single step, run to this point. I'm going to type some hex data to go into this register and so on. So that all has to be there.
I think Bob Sweeney had a debug question too, if he's still here.
Yeah, I'm reading this. Yeah. You want to just summarize, Bob, what you mean?
Yeah, I had some code running with no problem on the debug window. And last night when I turned it on, it's still running on the debug window. The text was, but it had an exclamation point at the beginning of the line. And then a couple lines below it, it actually had an exclamation point on both ends of the code. I looked it up. I couldn't find any discussion of what that might mean.
Man, I don't
Seemed to have the right
know.
answer, but
That seems like almost like something got corrupted or something, because that wasn't in your code to put an exclamation or
No.
exclamation point, right?
no, that's why I was looking through the docs trying to see if that meant something. And
You
I
know,
reran it several times and it still did it. So I just didn't know what changed between you. I ran it again.
Yeah, that's 21 hex. I don't know what that would be doing in there. That's strange.
Okay.
Yeah, I don't know why, but if you figure out there's a pattern to it and it's anomalous, then
Yeah.
we'll try to fix it. But I'm not sure why it would do that.
Yeah, because it didn't do it before, and then it wasn't until this morning when I reran it this morning, it just popped up and with no changes to the code. So what is a little odd.
Yeah.
Well,
that
other
is
than I
odd.
went, yeah, well, the only difference was I went to I downloaded, put in version 2.5.3 of the prop tool today. So that's when it popped up.
Oh.
That would be the only difference.
Okay, well, maybe now, was this exclamation point in addition to the text that should have been there, or was it substituting a character?
No, in addition, it was just
Okay.
like it just popped it in front and like I said, and then I think it was the last line, it had an exclamation point right in front and one in the back of it.
I'm wondering if
Then-
maybe there's something about Jeff's serial routines, which are kind of new. Maybe he has a one-off error somewhere.
Okay.
You know, he's
Yeah, because the
more
text,
data.
yeah, the text was there.
Is it still configured the same way? If you ran Pnut right now and opened up debug and hit reset on that thing to start sending the messages out again?
Yeah, I'd have to run. I'd have to get over to the computer. This is
Okay, well, no worries, but it sounds like maybe
I'll
something
try.
going on in prop tool, because if it's adding data, that is probably not coming from the chip, because that's all compiled in place and there's no way to like put an extra character in unless there's just
Okay.
some strange bug.
Yeah, I'll
No,
try it on Pnut later.
Okay.
any chance there's noise on the serial lines or anything?
Nothing's changed. Like I said, I didn't change anything from when it ran, other than changing the prop tool itself, and
Yeah,
pretty
it
short.
must
Just
be
wondering
something
if
about the
we got
serial.
in the serial stream, that's all.
Yeah.
Then it sounds like what Chip's talking about is right.
Yeah, if it was noise, I'd expect to see it in different places, but every time I'd rerun it, it showed up on the same exact lines each time.
Oh,
So,
yep.
Yeah, it wasn't random.
Yeah, that is weird. I don't know.
Yeah. Okay. Like I said, I looked at docs. I thought, well, maybe it was something I missed, or but if it's not something you put in there, I'll do some more deeper digging, and necessary, send you some code, show you what's going on.
Okay.
If I
Yeah.
did have another question.
Yeah.
When you're instantiating the debug window, it seems like you have to have everything in that first line. You know, how fussy I am about neat programming. And, you know, I have this line that goes all the way across the window because I'm setting the title, the size, the back color, and the position, and putting it in the manual update mode. I wanted to break that up, but it seems not to work if I do that.
Oh, yeah, because there's some stuff that needs to be in the initialization. And then there's other stuff that needs to be for like feeding it routine data. So the initialization would have to do with stuff that once it's set, it can't change, like the size of the window
Right.
or the color mode or the background color. Well, actually, some of these things can change. Like in this case of plot, you can specify background color in both the instantiation and the feeding lines. But let's see, and you can change the color mode too. You can change the LUT colors. You just can't change let's see, the size of the window, you can't change. The position of the window, the title of the window. Those are the three things you can't change. And then update means you're putting it in update mode, not updating it.
John,
Right.
you, Tom?
Yeah, that was a little, because I wasn't sure how to do that. I was trying to follow your examples, but in my instantiation line, I have update at the end of everything. And that seems to put it into manual update mode, because if that's not there, then the windows seem to be auto updating and it was flashing and doing all kinds of crazy stuff that it didn't want.
Yeah, the idea is if you want to like make a pretty window, you clear it, you do all your drawing, and then you say update, and then it will promote that to the visible bitmap. So it's kind of like.
Yeah, that's what I'm doing now.
John, can you show us the line? Can you do a screen share?
Yeah.
Yeah, you had to have set update mode on your instantiation line to put it into that mode so that update will have effect. Otherwise, I think update doesn't really do anything. It would probably update the window, but the window was already updated from the line draw or whatever you did.
Yeah, so here's the instantiation line.
Yeah, so you put update, so you put it in update mode, so it will only update when you specify update later on.
So,
right.
John, couldn't you define that string as byte arrays in memory and then just debug that the starting address of that string?
Yeah.
Oh, yes, yeah.
So now you can define it as your different groups with just by having them approximate to each other, they'll concatenate, right?
This is a
this is
a first world problem. My anal retentive programming nature. I don't like, to get out past, I don't like my code to go past where I want to put end of line comments.
And that's why I'm suggesting just put an org and end and then bytes and then reference that variable right there in the.
All right.
Right there in the setup method.
You know,
you can break
first world problem. This is everything is working. The code looks nice. Got my friend excited. Ken seemed to like it. I knew Ken would because he loves to do remote control stuff. So I'm glad he likes it. And because of my, my slightly arty nature, I want to find other ways to exploit the plot window to do really neat outputs. It's not going to be LabVIEW perhaps, but at least we could do, find ways to do really neat kind of things that make it very easy to use without having to resort to external products.
Right.
Well, everything it draws is anti-aliased. It looks as pretty as the display can make it look, shy of being pure vector data.
One of the things that I was going to ask, Chip, that seems to be, if I run this again, and this I could be wrong, but I was struggling at times to read, this code. Now you're looking at my laptop screen, which is a 4K screen, but I have screen scaling set so that I'm treating it like a 2K screen. And yet the debug windows don't seem to scale. These seem very, very small. Maybe I'm wrong. Maybe they were just always small. But
in Pnut, it just borrows the text size from the editor to set up the debug output. But Jeff probably didn't do that. He probably just made it default to like 8 or something.
Again, another first world problem. I'm not using this window anyway. This stuff.
Yeah, that window, that green and black one, that's just there if you need to do a reality check and find out.
Yeah. Again, I'm happy that I got this going because I feel like I can exploit the rest. But now it's finding opportunities to do neat examples, because we talked about last week. We're going to inspire more people to join our ranks by interesting examples that aren't overly intimidating. I think we all tend to do that, but one of the things that I know I'm guilty of, and I would suspect others are, is I assume that if I understand something, you do too. And we know that's not the case, especially with beginning programmers. And for those of us that enjoy spin so much, we're already at a social disadvantage, if you will, because it's a new language. But it seems like my experience has been limited, perhaps. But when people will be open and say, "All right, show me how this spin works." Once they've seen the elegance of it, then there's no more of this. Well, it's not C. Now, I understand C programmers who have years and years of experience, like, Roy and Eric and those, feel comfortable in that environment. I completely understand it. But, there is, if somebody's new, why not learn, more languages? And I'll ask this out. In fact, I thought I'd send a note to a PM to Roy if I didn't, I meant to, but, it's clear I'm not much of a C programmer, but I want to be better at it. So, any of you that are really good C programmers who, if you were talking to the 18-year-old John McPhalen instead of the 58-year-old John McPhalen, what resources would you direct me to learn to program in C? Because I understand it well enough to translate it to spin, but I want to write some native stuff too.
For one book that gets recommended a lot for learning C is called Thinking in C, and it's online free. Just Google Thinking in C.
Okay.
You should be able to get the book. It might be available in PDF, but I think it's just a website. I don't know. It's hard for me to do that because I learned C when it was, in the 80s.
Well, and I bought the K&R back, when I first started working at Toro. So I've had a copy of the K&R since 1984 or so. And, in fact, the examples in that won't work as is because you have to include, standard IO to make them work. But, I have that and I review it all the time and I feel like I'm getting better. But I thought, there are people like you that are making their living programming in C. And I downloaded and started looking at your FastSpin. Is that what you call it? Your compiler? Now, I'm never going to
OpenSpin. Yeah.
OpenSpin, sorry. I'm never going to write code like that. But I figure, you're a professional C programmer. I want to see what professional C programmers do. And so that if I do decide to write C code somewhere, I don't want to embarrass myself by putting something out that, what I don't want is, so my expectation would be if I put out some really bad C code, you'd call me up and say, "McPhalen, what are you doing?" That call.
OpenSpin's a good example because it's where it's C++, but I intentionally kept it closer to C instead of C++. And that's my preferred place to be when I'm writing C++ code, is in that closer to C type C++ code. In my professional work, it's much more C++, working on a team, and you have to deal with blending in, 20 people's code into hundreds of thousands of lines of code. So, yeah.
Okay, thank you for that. I found a link to that, so I'll sort it out after we're finished today.
Yeah, and it is 2 versions, right? You want to make sure you get the C one if that's what you're really
all right. Yeah,
for,
it's funny because I see one that
++.
says volume. Well, yeah, I clicked on an image and I just now noticed it says Thinking in C++.
There's one of each.
I'll find the original.
But yeah, they're both good. It's just
Okay.
that you got to be aware that we don't really have C++ yet. I mean, we do in a couple of interesting forms, but it's not well supported yet on P2.
Okay.
John, was one of the things you were asking for trying to get your code to split over 2 lines?
Mm-hmm.
if you put, I believe if you put an opening brace at the end of the line or before your text or before your comment if you want, and then on the next line you put a closing brace, the compiler will ignore between the open and closing brace, and therefore the carriage return line feed also gets stripped.
Yeah, I've done that, and I didn't think about it last night, to be candid, but you know, that also, yeah. Again, I'm an anal retentive nut, as you know, when it comes to formatting. And I think I've had one spin program in all the thousands of spin programs I've written that I had to do that, and I had a lot of locals, and I was using very verbose names, so I did that. But you know, I have this maniacal desire to write really simple looking code so that, you know, anybody, you know, including people that may not have the experience that I have can understand it and make use of it.
Yeah.
And I'm a visual person. I'll admit I have these weird biases. You know, I live and work in the movie industry, and people there, for anyone thinking about writing a script, it's an interesting exercise because it's also a technical format. And there are these horrible human beings called readers that the first thing they do is not read your script. They just look at it. And if it doesn't look right, they throw it right into the bin. They will not even pass it along to the decision makers. So, you know, this is why there are, you know, people pay for screenwriting programs to make sure at least it looks correct. And then, you know, you move on. So that visual look of scripts and programs. In fact, one of the more entertaining days, I was working in a special effects shop writing spin code for a prop, and a movie producer came over to my computer and said, "What is that?" And I was able to explain to her. I said, well, you know how when we format a script, we do this? I said, I'm making that light up the way it lights up by formatting this code like that. So she understood the need for the technicality. Obviously, she didn't know what the code was, but I think it's again, the weird part of my sometimes interesting life is that it's art on both sides. From my point, everything is driven by the desire to be artistic.
Yeah, I think that's one of the reasons I like spin, because it forces indentation, and indentation is A, easy to read, and B, looks nice.
Yeah, in fact, when you know, during the P1 days, you know, before there was a language, because we had talked about, you know, do we have a new version of PBasic, and I had just encountered Python for the first time through a 3D program called Blender. And I saw it and I thought, oh my God, I like this because it's neat. It forces neatness, and it doesn't have all the extraneous curly braces and semicolons. And the only thing I find extraneous about Python is the use of colons on defines and loops. And I think there's no need for that.
Yeah, I totally agree with you. It's frustrating.
And in fact, when I'm going back and forth between Python and Spin, I sometimes forget that in Python. Oh, golly, why do I need that? I've indented what's below. Why are you doing this to me? But I liked it, and I showed it to Chip, and I think that would help. You know, the language, of course, is Chip syntax, but I think that the use of the block indenting was kind of inspired by Python. And of course, you know, all the borrowing of Pascal stuff and C stuff. You know, I like it. And I do say to people, again, because of what I do, I have this opportunity to meet lots of people that are doing these things that are not with the Propeller. And I say, it's always a good exercise, I think, to learn other programming languages, even if you're not going to put them to use, because for me, it teaches me to think differently. It's why I want to be better at C. It is certainly a standard programming language, gets a lot of use, and I'm trying to be better at Python because I learn things using those languages that I find myself incorporating into my spin code.
John, I think I worked up an example, but Chip, you have to tell me syntactically what it would look like.
All right.
I thought, you know, just experimenting. tell me if you can see that.
Yep.
And then what do I have to do to get the debug statement to actually send that string out? That's probably wrong.
Oh, okay. So you would just, is that a Z string, zero terminated
It
string?
is, yeah.
It is.
Yep.
You would just say in front of the at, you'd say, yeah, but put the, there you go.
I'm fat fingering it, sorry.
And then go, get rid of that leading underscore. So you put the at there and then put at plot setup.
There we go. And to close it.
Yeah, and that should do it.
John, you see what I'm thinking?
Yep.
Okay.
Okay, I might do that.
Yeah, you could do everything
like
like
that.
that.
That it is all very clean and there are comments that go along with each of the commands.
Right. Now, the only thing that I don't like about this is right here. So maybe instead you might want to do this. So you don't have to worry about trailing white space.
Oh, sure.
None of our
Yeah.
eyes, none of our eyes ever look for trailing white space.
Okay, yeah.
Just thoughts.
Oh, I see. Yeah, you'd have to do that on every line. So I would probably decline to do that and live with the trailing white space. But
Okay.
But I like that, you know, it's separated out. It allows, because this is a good teaching mechanism. And one of the things that I frequently do is I will put DAT sections right above the methods that they apply to. You know, sprinkle them through the program. So that plot setup stuff, I would stick right ahead of setup. And so now they're right together and it makes it really clean and easy. Yeah, that's exactly how I would do that.
Sweet.
Now, Stephen, one thing you got two single quotes on that second line of bytes.
Oh, yeah. Yeah, it doubled on me when I typed it in. Thank you.
Yeah.
That looks good.
Yeah. So
Yeah.
again, doing it like this, I'll do
pardon
this
that.
in my examples so that again, part of the reason for, you know, is to share that program to inspire people to build other things. This helps with specific, you know, to show that how things are actually applied. One of the things that my friend that I was building this sbus thing for, you know, he started with a basic stamp and he said, you know, I really miss you know, I wish the Propeller had the basic stamp type manual where every single command or statement had an example with it, you know, and with even the P1 manual doesn't do that. It would be really nice. Now, you know, it becomes a really thick manual for the P2, but I still think it would be worth doing, especially with the assembly instructions. You know, I thankfully, again, with Evan and Tony, we're really good about saying, hey, look at this instruction and see how it, you know, it works. Yeah, so the code is nice and neat now, and I'm happy about it. But, you know, again, for those of us that are trying to inspire more people to join our ranks, you know, we have to give them nice, neat, small examples that are easy to digest, you know, cookbook kind of thing. Steve and I had talked about that before, having little cookbook of code samples.
You got it. Hey, John, I moved the white space to the left edge so we don't. What do you think?
Yeah, that works too.
Yeah, it looks good.
I kind of like that because it
lines up. Yeah. And again, you know, our eyes follow, you know, lines.
We'd understand this would be intentional. Well, we would think this is an accident. Yeah.
Yeah, I think I agree with you. I'm going to adopt that second style.
Okay, so there's an example.
You know what this means? You can do all your debug output with actually a single debug statement that you dynamically redirect to a string.
Correct.
But what you don't get though is like the compiler to put in the equations for you to solve at runtime. You'd have to do that separately and then generate the string data for it.
Yes. So you'd have to have a format from memory to memory to format the numbers.
But you could use, you know, we have, you know, formatting, you know, like string formatting routines too that we could probably use.
Correct.
Generate a string on the fly and send it out.
Yeah, just write to an output pointer or memory pointer instead of.
Yeah.
Yep, instead of the debug port. Cool. So just thought I had an idea. It worked.
Cool. Yeah, thank you, Stephen. That's really nice.
Sure. Did you screen capture it so I can make it go away?
Yeah, I got it.
All right.
Hey, Ray, do you want to show what's blowing up?
Yep, sure. Let me go to screen share. Okay, so you can see that.
Not yet. It's not sharing.
Okay, I hadn't clicked the share button.
There we go.
I do
Okay.
that all the
let's
time,
see.
Ray.
Okay, you can see I've got that enabled. The 2 meg is disabled. If
Yeah.
I do a run,
Okay.
Nothing.
no display. Now, what's this? Comment that out, save it, Control S, run it, got it. Comment that
Okay.
out, save
you
it with
paste
Control
it?
S. Hang on, just see.
Right. Okay. Can you paste it just into the chat window so I can load it in?
Chip doesn't like us running at that speed.
No, I don't.
It's way too slow.
That didn't, oh yes, it did. Yep. Okay, where's this? Lost the send button off my screen. Where's this?
That's a feature.
Carriage return, of course.
Nice. Good
Okay.
light bulb test there, Ray.
Yeah,
grab
there's
that.
some suspicion that CP2102 won't run at 2 megabaud, but I have to say that I can download my CPM code, which I think is about 70 kbytes at 2 megabaud using load P2 without any problems at all. So maybe there's some problem coming back the other way. I don't know, but
Well,
I think
it's running on my system right here.
well, yesterday it ran and it was intermittent, and I was playing around with putting different things in, thinking, oh, maybe it's the terminal's too slow to get started, so I'll put a wait 500 milliseconds before the repeat loop, and I was playing around backwards and forwards, and all of a sudden it went hard on and failed solidly, and I got to this point. And I've repowered my PC, I've repowered the P2 eval, and I've reloaded everything, and I've still got it hard on.
Well, you know, I've got it all the way down to 9600 baud now, and it's working. I wonder why. Well, I could probably even go lower than that with. Let me try at 10 megahertz. Maybe I could even do like, let's see, 1200 baud. Yeah, even 1200 baud works. I wonder what the difference is.
Good question, because I don't know.
Real quick, John, I put some book recommendations in chat because I was wrong earlier.
Thank you.
Also, maybe your other chip just is using the standard baud rates and not something like 400 baud or 2000, or it has to be a multiple of whatever. So it just uses the standard baud rates like 11, 15. No, I mean,
yeah, like maybe
multiples of that, you know.
Yeah, maybe yours doesn't have that timing option. I even got it going down to 600 baud, but
this is using a P2 eval. I don't. So I think there's an FT232 on that board, isn't there?
Oh yeah, let me take my P2 eval board.
Because the first thing I wanted to do was to get rid of my CP2102 and make sure that wasn't causing the problem. But when I got to the P2 eval that was failing, I thought, this is not the problem I was thinking I was chasing.
I'm running V35I.
Yep, that's what I'm running. V35I.
Oh no, this is interesting. Now it didn't work.
Aha.
I'm on a P2 eval. So let me put it to 2 million.
Yeah, I was just about to try that
works.
myself.
Now if I go to 1 million, yeah, that's just the strangest thing. It's like,
Yep, I just tried it too. Yeah, I'm back to 2, and yes, 2 works with the comment in, with the line in.
so there's some difference between the P2 eval and the prop plug.
Interesting.
It has to do with the FTDI chip's the only difference. And you know, this came up on the forum. Someone noticed that the chip was IDing as something different than we thought. Now these chips look identical to me, but let me get my eye loop. Now, this is an FTDI, it looks like 231XS. Does that make sense? FT231XS. And then on the eval board, it is it's FT231XS also. But you know what? There is some configuration that goes on with these things. And because I remember when we built these FT231XS, we must have configured these chips differently, but it's not something that you can't reconfigure on your end too. I just don't know what the trick is, because I know on the eval board, we set it up so that some of the pins would operate the, there's like something to do with the power sensing and the power switching, and then the LEDs, which indicate TX and RX. And there must be something different about the way we configured the prop plug. And I don't know what the difference is, because I never did that work. Von Sarvash knows. And I don't.
Well, I just tried 115-200 chip, and I would expect 115-200 to work.
Totally,
on the FTDI chip, and it does not work.
Well, I think what's happened is the FTDI chips have some kind of non-volatile memory in them. And I know that we configured them through some sort of application for the P2 eval board. And I don't know that we did that for the prop plug, but there's some kind of like settings difference between the two. So what we need to do, here Lachlan wrote, FT program lets you set PID, ID, and FTDI chips and invert DTR, etc. So I think this is what's happening. We're configured differently. Same chip, but we configured it differently.
Why would that matter?
I don't know.
Aren't you only changing the board?
Yep.
So if you're only changing the board on the chip and the serial port.
Yep. I mean, it's obviously the same driver in Windows, because I see.
Yeah. Because I can download to it fine. And of course that's happening because we're downloading this code in there. I haven't tried outputting anything to a terminal.
Yeah, I wish I knew what the story was behind this, but I know that we had to, before we could download to the P2 eval board, we had to configure that FTDI chip, and there must have been something in our configuration that makes it not work like the prop plug simply does.
But see, I'm running a CP2102 with the typical transistor inversion on it into my RAM blade, and it doesn't work there, which is where the problem came, because I was chasing down, does the CP2102 not function at the high speed? So, I mean, because you really should be running to any USB to serial device. There shouldn't be anything specifics in there.
Yeah. I can
Now,
run
there's something strange with setting the board, as in board speed, because it's not board rate. Very pedantic on that.
Right.
About if I change this.
Yeah, I can go to 600 baud. So for some reason, the prop plug has more flexibility than the chip. It's the same chip, but it's been configured differently at some level. So we've got to talk to Michael about this because he knows. I don't know anything about, I knew this was a step during manufacturing, but I didn't know what it was about.
That doesn't solve the problem with if there's a configuration problem with, well, I guess if you find the problem with the FT232, you can find out what's going on and go back to your code, but it's your code that's going to have to change. It's not the FTDI chip that's going to have to change.
Well, no, I think the FTDI chips have been configured differently and now they don't act the same.
I'd have to reconfigure the chips. Is it even possible once they're in the eval board?
Well, oh yeah, you just talk to them over USB and you can, we just need to know what we programmed into each. There's something different about the prop plug configuration versus the P2 eval board.
Sweet, okay.
And I knew there was something about switching power and some LEDs, but I'm going to have to ask Michael because I don't know.
So if you're doing something, so you're configuring, because you talk to a USB chip from the PC, which is what's happening, and you tell it to change speed. Now you do the same thing to a CP2102. Now load P2 can change my load. I can load into my board at 115/200, or I can load it to megabaud on the CP2102. So if you're doing something specialized for an FTD chip, you're going to need to be generalized rather than specialized.
Well, I'll show you what I did, which I was kind of surprised that it worked. I just changed, without like closing and reopening the port, I just changed the baud rate. I'll show you the code here. Let's see. I was surprised it worked. It was kind of like, oh, I guess that's all I got to do. But maybe it doesn't work with everything. Let's see. Where did I put this? Somewhere I configured.
On that CP2102, Ray,
yep.
I get exception errors if I try setting baud rates over 1 megabit.
Well, load P2 certainly set, well, it implies it sets it to 2 megabaud, and it certainly loads it. I mean, I'm loading a CPM's a reasonably big program.
Yeah. Yeah,
and
the data
it
sheet
loads fine.
Goes to 1 megabit though.
Sorry?
The data sheet only says that it goes to 1 megabit.
Okay. Well, it may do that, but it's certain unless there's something, unless load P2 is lying, it's configuring it to megabaud, and it's working.
That's where it's weird, because I can go into PST and set it to 2 megabits and it doesn't error or anything like that, but it just doesn't work. In fact, I can't get the CP2102 to work at 1 megabit even. 921K is as high as it'll go. So it's weird.
I can show you the code that I'm using. Maybe I mean, I did it kind of abruptly and it worked. So I just figured, okay, I guess that works. But I would think they'd want you to like reset the whole thing before you try to do something different with it. But I'll show you what I did here. let's see. I want to show, oh, here we go. Let's see. There, do you see that? So the port's already open. I just do this COM-DCB and then use it to set the already open port, just sort of changing the baud rate on the fly. And this works, so I figured, well, that must be all you need to do. So maybe though, what I need to do is do something where I back it out and run it through some deeper reinitialization. But you see, if it
Because
says
the problem is, if you've got to reconfigure it totally, then it's probably going to drop DTR.
well, that's the problem. Yeah, I was happy that it just let me switch that one thing.
But Node P2 is doing it, so I don't know what they're doing in Node P2. I've never looked at the code because you can download it at a different speed.
Yeah, now the open COM port, I'll show you. No, wait. Oh, brother, why does it think all my files change time? Okay, I'll show you the open COM port. Okay, so here, I'll put down here. Here's the thing that I initialized the port with.
What I find irritating is that you are comparing to 2 million and not to your constant debug baud.
Well, 2 million is just what it should be by default. It's good to use constants in code wherever possible, right?
No, I mean, you have that constant in P2 code and spin 2 to set debug baud.
He's pushing your button
at 2 million.
Oh, you mean this
here
here?
you are comparing with 2000. And, I mean, not.
Oh, you know what I could have done? I could have just done everything at what instead of using 2 million. Maybe I just should have done this from the start.
Should that be somehow referencing to the value out of the spin program?
Wait, say that again, Michael. Sorry.
In spin, you can set the constant debug pin and debug baud.
Yes.
So to change the speed. But if you are here comparing to a constant 200,000 or whatever it is, 2 million,
right.
Shouldn't you compare that to that value out of the spin program, the value?
Well, that's what this is. This is what the person puts in the compiler. So, and it defaults to 2 million. So if they don't specify a value, this is 2 million.
To 2000, aren't you switching to it anyways?
Sorry, you broke up. Say that again.
Yeah, by build COM-DCB, you are setting it to 2 megabaud anyways.
Yeah, now here's this is the initial one that I set the port up with. Right, this is the first thing that I do. And then later I come back on the fly and I go, do we need a baud change? If so, do it.
Yeah, okay, yeah. There you switch to the PC debug baud. Okay, yeah.
And I don't know. I mean, this is just how we've done this since day one from 1996 on the SX stuff. This seemed to be what was needed. Let's see, what is out here?
Existing,
Yeah, these are just some things that
Yeah, so my question would be for Cluso, if that thing maybe hangs up on if P2 load maybe switches down to a lower speed. Can you maybe put a scope on it to see if it's really transferring at 2 megabit?
oh, I know it is because, oh, well,
You know,
when
on
it
Cluso
fails,
port with that other chip, with that CP, whatever.
yeah.
Because it works on FTDE, but it doesn't really work with Clusos. So there is some difference in handling of how the chips handling. Either they don't like those variable speed, or they don't like more than 1 megabit.
Michael, I'm on a P2 eval that's got an FTDI chip. It's a 231 XS, but
yeah, and it's still not working.
It's still not working. So
it's the same chip as used on the prop plug. It's just been configured differently, but let me make sure these part numbers are the same.
Yeah, I did that already.
Yeah, 231, FT231XS on the eval board. And then on the prop plug, FT231XS. It's the same thing.
Yeah.
It's just been configured differently. And somehow that configuration makes it behave differently. We're going to have to talk to Von Sarbosch. He knows what's going on here, or he'll know what we're programming into these things. But I think, I mean, that it works in one of these chips. Uh-oh. Why does it think all my time things changed? We're just going to have to ask Michael about it, because it's something that, I mean, it works, but it doesn't work the way we've configured the eval board.
well, it's not just the eval board. It doesn't work on the CP2102, and you shouldn't be specific to having to use a specifically configured. Yeah. But I do have I'd have to do some soldering. I can change the link on my board. I've got a prop plug equivalent, an FT232RL with the transistor reset on it and still powering my board. So I'll jump that over. Afterwards, I'll have to disable the transistor reset on my board as well and try that.
All right. I think what I could do, I could try this on my, in fact, here, I could try it right now. What I'm going to do is I'm going to copy that and substitute for the 2 million right here, right?
Yep.
Okay, here, I'll do this right while we're on the thing here. I'm going to close all these windows. Let's see here.
While you're doing that change, Chip, at that top section, if you took out the if, hey, that if begin, does the begin and end have to be indented? What language are you using?
I'll just comment out the guts.
Yeah, because I was saying, you know, always send the output.
Yeah.
To change it and see whether that does anything.
Right here, let me, okay, I've got that done. Now let me cancel out that other business. Let's see, where'd I put it? Operate debug, here it is. Okay, so I'm going to cancel out the guts of that. Now I'm going to run this. I got to use a plus here. Okay, we're up. Now I'm gonna grab your program again. Let's see, where'd the little chat window go? Let me stop sharing for a sec. And I'm gonna copy your program again. All right, now I'm gonna plug the P2 eval back in. All right, let me run this. I got some kind of an error. Why did that happen? Wait, something's wrong. Oh, you know what? Okay, I have got issues with Zoom and Delphi. Something funny is going on here. I'm gonna try again. All right, here we go. Oh boy. Wait, editor form. Hold on, something's really messed up. Let me get all the way out of the car and back into the car.
Press the start button to shut down the car.
Save changes to Pnut. No, I don't think I made any changes. All right, now let me get back in. Sorry about this. Okay. Okay, now let's see. Let me go into that thing where I was opening the port up. Oh, boy, this is all wrong. You know, we never could figure out Delphi's internal logic for where it pulls files from. There's some stuff that it does that is just hard to know. Okay, now, okay. All right, serial unit. Okay, here's operate debug. So I'm going to cancel out these two lines. Int to string P2 debug. And then I'm going to put this down here. All right, now. You know, there's something really funny going on. It says editor form, not Pnut at the top of my thing. Like it doesn't know, it doesn't know who or what it is. Hold on here. Let me see if I can just open and run anything. Here's the 5 buttons, 1 pin. Okay, this is working. All right, now let me grab that stuff out of the chat window again. Untitled. Okay, now I should be able to test it. Okay, it worked. Let me see if I can go to 600 baud. Wait a minute. Oh, it can't log in at 600. Let's try 1200. It's timing out. Let me try. Let's try 15200. Yeah, okay, that works. So it is something about reinitializing, but I can't. But it's funny. I can't I have to download at 2 megabaud because all the timing, the framing is set up for, those kinds of time constraints. Because, we have, after we reset, we have a little window we have to respond in. That conversation can't occur at like super low baud rates. It'll time out. So we have to be kind of high. But it does seem to be, it is so that if I set that thing once at the beginning, it works okay. All right, so I'm going to have to figure out, well, Ray, I have everything here I need to determine this. I know what the problem is now. Now I have to figure out how do I change the baud without causing the P2 eval to fail. But I do need to do the initial talk at 2 megabaud.
Right. Oh, okay. That may or may not be an issue with using non-prop plugs. But let's see whether we can fix that issue. And I'm meanwhile, we'll have a play around with seeing what speed is reliable, trying to send a whole pile of data backwards and forwards across this CP2102.
Yep. Okay.
See what speed it can really do. Because as I said, I've had no problems at 2 megabaud.
Yeah.
So that sort of tells me that maybe it will run at 2 megabaud and there's some other issue that's occurring.
Yeah, there could be. Yep. So anyway, I can see the problem here. I can replicate it and I can know when I fix it, at least to satisfy this P2 eval board. And then what I'll do is I'll send you a version and have you try it out on your setups.
Yep, that'd be great.
Okay.
Okay, now while you're talking about that, I want to ask a question regarding inverting DTR. Because I don't think you're inverting DTR, are you, with a transistor? Remember the transistor reset circuit you had on the prop plug for the P1?
Yeah.
Well, I duplicated that transistor reset on all my boards as an option. And what that actually does, it actually does a reset pulse on the going away of DTR. That's actually the function of that transistor reset. So, and the reason that was, with a lot of work I deduced and found that why you implemented that on the P1 was because when you go between one program and the next, Windows drops DTR and that caused the reset. Now, if in PST, when you load PST up after you've downloaded with PropTool, if you don't set DTR back on again with PST, you don't actually get a reset. So that's the function of that transistor. In P2, you've decided to just use a capacitor and generate a pulse off the active edge of DTR. I've put on my board the option for that transistor reset because I still think there's that issue with Windows.
Yeah.
And I've mentioned a couple of times that it's not on your boards, and I don't know. It's fine if someone uses a prop plug, but then when you're using a prop plug on a P2 edge, you're effectively generating a reset pulse on the going away of DTR, correct?
I think so.
Yeah, that's not good.
No, that's what it should be doing, because there's, Michael, what happens is that PropTool does a reset, toggles DTR. It would have to actually toggle it twice. So it then places DTR on. Meanwhile, you've done a reset. Forget where the reset actually occurred, but you've now got DTR on. When you pass control from PropTool to PST, Windows drops DTR. If you don't invert the DTR and set the reset pulse off the rising edge of DTR rather than the falling, I got that right? Yeah, when DTR, when you switch between Prop Tool and PST, Windows drops DTR, and bingo, you've got a reset.
Yeah.
But if you do it on the rising edge, then you can bring in PST, do not touch DTR, in other words, do not activate it, and therefore you haven't done your reset. And that's what that transistor circuit does.
Yeah, it's my understanding too, yes.
Yeah. Now, my concern is that, and I've expressed it a few times, which is why I have on my board, I have that optional transistor reset circuit, so that I can enable that if need be, and I tell people to put that jumper on, and that's the way I run it. So I've got the transistor reset circuit enabled, because remember, I'm using a...
Is the reset disable jumper?
No, it's not a reset well, it actually is a reset disabled jumper, because if you don't put a link on there, you have actually disabled it. Yes, the big mistake I made.
Jumper would be better, so that you can kind of, I mean, in my opinion, even a switch would be the right thing to do. Program, not program. But I mean, the only Baud parallax that would right was the web server thing, Spinneret. They had the jumper for programming and not programming.
Yeah, well, the mistake I made with the RAM blade, because I had it originally on a really tiny board, and then I widened it to take the VGA connector. When I widened it, I didn't go in that little area and widen it back up from just a straight little soldered link to make it 50 thou pitch, so that I could put a little header on it.
At least the small jumper, you know,
Yeah.